F. Questions from assignment 4, 1F. What's weird about 1F when you want to try and graph it? It fits fine. When you try writing it in slope-intercept form, what happened? You know what? To get the y by itself, eventually you would end up dividing by 2, but when you divide that 5 by 2, it's going to be a fraction. Oh, and in the second one, to get the y by itself, you divide by 2. You're going to get a y-intercept, Carl, that's a fraction, which means you need a different method to graph. The best method to graph, Brendan, the best method, it's in your head. Let me show you what I mean. Rachel, my angel, can you read to me this first equation here out loud, nice and big? And I'll zoom in so you can see better, although in theory it's also in front of you because you have the assignment in front of you. Can you read to me the first equation?
X plus 2y equals 5.
What I hear is a number plus 2 times another number has to work out to 5. For example, Rachel, supposing x was 1. If I put a 1 right here, 1 plus what equals 5? In your head? 4. How could I make that work out to a 4? That's a point 1 over 2. That's a point on that line. This is how I graph, by the way. If you ever see me graphing lines, I don't rewrite them. I try numbers in my head because I'm good at arithmetic in my head. And it's the fastest and it's the laziest. Let's try another one. How about if x was 5? Jordan? I know 5 comma 0 is 1, 2, 3, 4, 5 comma 0. Now, I did also try x being 2, but if x is 2, what does this have to be? 3. Can I make that work out to a 3 evenly very easily? So I skipped it. It didn't work out nicely. Oh, but what if x was 3? 3 plus what is 5? How can I make that work out to a 2? I said, you know what, 3 comma 1 is also on, and now I spotted the pattern. It looks like we're going down 1 over, I can graph this now. And I got to do the same thing for the second graph. Kenzie, my angel, can you read to me the second equation here? This one is tougher, Kenzie, because it's a 13, it's bigger, and there's a negative. So I went, well, 9 plus 4 is 13. 13. Is that true? If I put a 9 there, I need to make this work out to a plus 4. You're saying when x is 9, y is negative 2. That's x is 9, 1, 2, 3, 9. Y is negative 2. And by a wonderful fluke, I just found where they cross because I've already put a dot there. But let's find a couple more. What about if x is 7? 7 plus what is 13? 6, except there's a negative there, so I don't want to put a 3 here. What do I really want to put? If I put a negative 3, because that'll give me a minus minus and turn that into a plus 6. This is really, Kirkland, the laziest, bestest way to graph as long as the numbers are small. You do, 7 comma negative 3. I think it goes, I'm looking, it looks like it's going up 1 over 2. I'm wondering if that point there will work. 5, negative 4, I put a 5 there, plus, yeah, you know what, that point works. So it looks like that. It looks like that, and that's where they cross. Am I going to give you one like that on your test? I think in your test they'll all work out. You can do them in slope-intercept form, Jack. But for what it's worth, if it's not in slope-intercept form, it's doable. Or sorry, if slope-intercept form gives you a fractional y-intercept, it's doable. I can still find whole number points. So having done that one, were there any others that you were going, yee, I don't know how to do this? Pause for a second. Lesson 6, applications. What you used to call word problems, but we've decided to call them word opportunities. Mr. Dueck? Yeah. Are you going to put like 10 of these on the test? No. Maybe 2, probably 1. Maybe 2, probably 1. They are going to throw one at you on the provincial. Now, here's my argument. Word problems, if you know systems of equations, word opportunities, become easier to start. And I'm going to try and teach you some tricks of the trade. So you ready? Jumping right in, example 1. You may have noticed when I start out with a word opportunity, the first thing that I tend to do is read it out. So, Jake, my friend, Jacob, can you read out example 1, please? Out, big, loud voice. And my first bit of advice to you, Kenzie, my first bit of advice to you, Halen, when you get a word opportunity, read the thing to yourself, but in your mind, imagine you're reading it to yourself like in a loud voice auditorium. I kid you not, that helps. Don't ask me why, but it does. We'll actually read it out. Jacob.
The difference between two numbers is 9. The larger number is 3 more than twice the smaller number. Find the numbers. Okay,
first thing I always ask myself is, what are they asking me to find? The numbers. I need some variables. How many numbers? 2. What might be... Okay, so I'm going to say, now, Rob, I want to be organized, clear, and lazy. So when I used to teach this to Math 9 kids, we would do these things called let statements, where we would actually write sentences. Let the first number be X. Let the second... You're grade 10s. You ready? I would do this. X, arrow, first... What is the tic-tac-toe symbol like that, an abbreviation for in the English language? There. X is first number. I think that's clear. Comma. Y is second number. I also like this, Jack, because I've written something down. My question's no longer blank. There is opportunity here. Go back, Jake. Read to me. Start at the beginning. Stop. You guys laugh. This is how I rip word problems apart. Difference. That's a math word. What does it mean? Which mathematical operation does difference mean? First of all, can you tell me some words that mean add? Obviously, add does. What other words mean add? Some, and, and means add everywhere except in probability mathematics. In probability mathematics, turns out and means multiply. So if you want to find the odds of rolling a 6 and getting a heart, you actually multiply those two numbers. You don't add them together for what it's worth. But everywhere else, yes, and what else? Sum, someone said. Total, yes. Okay, what are some words that mean subtract?
Different.
Okay, difference means subtract. What else? Minus. What else? Yeah, you're right. I think you... did you say something with the letter L? Less than. By the way, what would greater than mean? Add. So okay. Start over again, Jacob, my friend. Stop. I kid you not, go like that. Because I just learned something from the question. There's going to be a minus sign. And again, have I written something down? Do I feel a little better? More opportunity. Keep going.
The difference between two numbers.
How can I write the difference between two numbers? Keep going. Is, stop. What does is usually mean in a word opportunity? That's generally saying there's the end of the first side of the equation. Keep going after the word is.
9.
There's equation number 1. Let's proudly put a 1 with a circle around it next to it. By the way, I'm already thinking I'm probably going to choose to use substitution, because if I plus the y over, it's going to be really easy to get the x by itself. And I like the substitution. Anyways, I'm already planning out all this stuff. Keep going. Stop. We got a problem. It wants us to distinguish between the larger and the smaller, but I didn't in my let statement. Which one do you want to have be the bigger number? Can y be the larger number based on that first equation?
No.
Why not? No pun intended. See, why not? Why not can't be, sorry? Huh? Oh yeah, it'd be negative. So you know what? Lazy but organized. Under first number, bracket, larger. Under second number, bracket, what? Now, this time I'm not going to cut you off. I want you to read the entire last sentence, middle sentence to me.
The large number is 3 more than twice the small number.
Do you see the word is? What does is mean? I'm going to keep my equal signs in line. Go back, read the first phrase up till the word is. No, the middle sentence still, the first phrase. Again, folks, you need to learn to rip each sentence apart. The first phrase up to the word is, the 3 words in front of the word is. Go. How would I write the larger number based on what I got here? X. The larger number is. Is that not what I've written mathematically? Read the rest of the sentence after the word is. Jack, quiet please. Sorry?
3 more than twice the smaller number.
Now, stop. Don't write. Here is the big secret to word problems. And I was only in my 3rd or 4th year as a teacher before I finally figured this out, because I couldn't figure out why are my students having so much trouble. And then I realized English and math are backwards from each other. So Jake, here's what I want you to do. Go to the end of the sentence. Don't read it word for word backwards, but read it phrase by phrase backwards. See if you can. Start with the word twice.
Twice the more.
Twice the, no, keep, go. See, here's what I mean. There's that, and then there's that. Read that second phrase that I underlined.
Twice the smaller number.
How would I write twice the smaller number? What times 2? Like, I'm not going to go like this. What did we say the smaller number was? Well, what did we say the smaller number was? Because I asked you. Say y. Twice the smaller number. 2y. Back one more phrase. 3 more than. What will I write for 3 more than? Now, in this case, you could have gone 3 more than 3 plus twice the smaller number 2y, but I'm telling you, if you realize that it's written backwards, that'll help you for more complicated stuff. You know what? I said I was going to use substitution. I said I was going to get the x by itself. I think I already have the x by itself in the second equation, don't I? I'm going to stick this right into here. Apparently, this equation is really x minus, oh, I'm not going to write x. What am I going to write instead of x in equation number 1? 2y plus 3 minus y equals 9. Is that okay, Brendan? I replaced every x in the first equation with a 2y plus 3. By the way, the nice thing about word opportunities, Curtis, almost always the equations will be fairly nice. Getting the equations is by far the toughest part. Almost always, though, the equations will be nice ones. Now what? 2y minus, y plus 3 equals 9. I think I did this in my head. What plus 3 equals 9?
6.
Really? It took you that long? 6? Yes? Y equals 6. What's x? How'd you figure that out? In fact, some of you did. You could have gone 2 times 6 plus 3, 12 plus 3, 15. Or, yeah, you know, honestly, Brandon, I probably would have just looked at this and I would have said, oh, I got the 6. What minus 6 is 9? 15. So you got 2 options to get there. X is 15. It's traditional in a word problem to close with a sentence. Well, you know what? What I mean by a sentence is not an English sentence. A conclusion. Large number equals small number. What's the large number equal? 15. What was the small number? 6. opportunities. Let's try another one. Example 2. Halen, my friend, can you read this to me, please?
The whole thing.
Yeah.
The largest jumbotron in the world is in Edmonton.
Stop for a second. This has nothing to do with the math. This is true. I stuck this in because, hey, it makes it vaguely more interesting, but I think I've already told you, I don't like the contrived word opportunities that we throw at you because they are kind of lame. It's, hey, if whoever built the jumbotron, wouldn't they know how big it was? I agree, but this is us practicing a skill. So from now on, when I say start over, you're going to start over from the second sentence because that first one is kind of meh. Keep going.
Okay. Its perimeter is 128 feet. The width is 16 feet less than its length. Find the length and the width.
Okay. What do you want me to find? Okay. I could use X and Y, but if I was really clever, what would be smarter letters to use than X and Y for length and width? Hey, let's use L and W because that'll be easier to keep track of. Now, when you write your L, make sure it doesn't look like a 1. So here's what I do. I always do a handwritten L, always. Otherwise, it looks like a 1. Okay. We're not using X's and Y's. It's going to be the same math. And I would argue we picked smarter letters because at the end we don't have to think so hard. So, Halen, go back, not to the beginning. Skip the first sentence. Read again.
Its perimeter is 128 feet.
Now, it's a rectangle. How do you find the perimeter of a rectangle? What is perimeter, first of all? Now, we haven't done it yet this year. We're asking you to go way back. Sorry? Outside, it's the distance around the outside. So, there's a rectangle. L, L, W, W. Yes? Can you come up with an equation that would describe how you found the perimeter there? That'd be area, length times width. Ooh, did you hear him? He even gathered like terms in his head. It is, by the way, L plus W plus L plus W, but he said, hey, that's 2 L's and 2 W's. There's our equation number 1. 2L, 2W. What was the perimeter, Halen? 128. I'll call that equation number 1. Can you read to me the next sentence? I guess the second last sentence, the whole thing?
The width is 16 feet less than its length.
Start over from that sentence now. Read that sentence again.
The width.
Stop. You said the width. What will I write? Read the next word. Stop. What does is mean? You guys are laughing, but there are some kids that really wonder where all this comes from. This is what I taught my grade 9s. This is how you rip a question apart. And some of you, by the way, do this instinctively and intuitively, and great. But for those of you that don't, this is your survival guide, is read me the last phrase.
16 feet. Oh, then it's...
He's going to read it backwards. Clever him, clever him. Its length. How would I write that? L. 16 feet less than. How would most people have written that? Most people, if they're reading it thinking English and math are the same order, are going to go 16 minus L, which is not the correct equation. English and math are written backwards. So I can't say go backwards word by word, but I'll say go backward phrase by phrase along the sentence, and you'll get it in the right order then. Which method are we going to use here? By the way, can I have a negative length or a negative width? Again, with word opportunities, there are built-in error checks. If you get a negative, Carl, you've goofed. Well, it's kind of nice. What method do you want to use here? Elimination or substitution? Substitution? I think I'd put that into there because the W is already by itself. Fellas, one more time and I'm going to move you. Okay? So I'm going to get this. Jack, wherever I see a W, what can I replace it with? Wherever I see a W, what can I replace it with? Not a negative 16. The whole thing. Yes. L. So it's going to be this. 2L plus 2L minus 16 equals 128. Yeah? Good. Solve that. Find L, find W. Add 32 to both sides, 100 and... Oh, hey, I like this. Am I right? Yep. I don't know. How did I get the width? What did you tell me I could replace every W with, Jack? So once I had the L, right? Remember, the substitution method is nice. Substitution method doesn't always work. It only works if it's easy to get a letter by itself. But if you can almost always find the second one just by going and plugging it back into the first, often in your head. Yes? Okay. Yes, yes? Turn the page. Example 3. Rob, why don't you sit up and in a big loud voice read example 3 to me, please, and wipe up the drool.
A large tree removes 1.4 kilograms of pollution from the air each year. A small tree
Hang on.
removes 0.2
Okay, Jordan, my friend, I'm going to have you move. Too much yakking back there, and it may be math related, but I don't think. Sorry, Rob, can you start over?
A large tree removes 1.4 kilograms of pollution from the air each year. A small tree removes 0.02 kilograms each year.
By the way, I'm already thinking, I'll bet you X and... Guys, stop clicking that pen. Come on, people. I'm already thinking that X and Y will be large and small trees, perhaps, but let's keep reading.
The park has 15,000 trees altogether, and they remove a total of 7,200 kilograms of pollution each year. How many of each tree are there?
Okay. What are they asking me to find?
How many of each tree are there?
Okay. What should we let our variables be? X and Y, large tree. By the way, you could go L for large tree and S for small tree. Have I told you why I hate using S as a variable? Looks like a 5, and again, is there plenty of room to make dumb mistakes in this already? So you know what? I'll go with X and Y. I'll go X, large tree, Y, small tree. And I even did the X big to jog my memory so that I know whenever I see X, think large. Stupid, but it'll work. Okay. That first sentence is an equation. Well, no. It's part of an equation. That second sentence has an equation and the second half of the first equation in it. We've ramped things up. This is a tougher question. So the first thing I would say is this. How many large trees are there? X. Yes? How many small trees are there? Y. Because I asked you. There are Y small trees. How many trees altogether? How could I write that as an equation? Sarah, did you hear him? Sarah, did you hear him? Say it loud. You're right. So, as we're learning math words, the word altogether, what mathematical operation does that one suggest? No one mentioned this before. Add, right? If I say, how many do you have altogether, what I'm really saying is add them all up. So I think one equation is x plus y. Altogether, we have 15,000 trees. That's equation number 1. Kirkland, how many variables did I write down here? How many equations am I looking for? So I better find one more. What haven't I used yet? What numbers appear, or what information appears in this question, Kirkland, that I haven't used yet? I haven't used the 1.4. What else? Is that a hand up or a stretch, Brendan? Oh, you're answering the question? You're participating? Oh, good for you. Okay, I like you again. And what else? One more thing. I'm guessing somehow those will fit together. You see, I can kind of give myself some hints by just being, Sarah, clever. All right, how? Okay, I got you. You know, you're doing okay. So now I'm going to say shush, and I'm glad you're doing okay, but I'm going to say shush. Katie, what? 1.4 times the number of big trees, and plus, keep going, 0.02 times the number of small trees apparently will add up to how much pollution removed. Okay, this is sort of almost like a price question. Anyways, let's try. So you're saying 1.4 x plus 0.02 y equals 7,200? What's a bit yucky about this equation here? Decimals. Do you like decimals? Then I'm going to give you a great trick. I'm going to multiply everything in that equation by 100. We're allowed to, because we already did say you can multiply equations as long as you multiply everything, and that's the same equation, yes? So why don't I multiply by 100? That'll clear every decimal point out. I could have multiplied by 10 if it was just 1.4, but that 0.02 has 2 decimal places. I'm going to go like this. Times 100, and this is going to be my new and improved equation number 2. It's going to be, what's 1.4 times 100? 140x plus 2y equals 72 with 4 zeros, 720,000. I mean, those are big numbers, but hey, no decimals. That's, in fact, Brendan, that's technically what we did to clear fractions. We multiplied everything by the common denominator to clear fractions. You want to clear decimals? Multiply everything by a 1 with the number of decimal points you need to get rid of. So 2 decimal places in the second number, 100, 2 zeros. That's equation number 2. Substitution or elimination? You want to do substitution? So, what do you want to get by itself here? Because I asked you to. What do I? I'll never get tired of that. Okay. What does y equal, apparently? I'm going to go 15,000. Take away x, because that looks prettier to me. Negative x plus 15,000, perfectly acceptable. I just know I make more mistakes with negatives than with subtraction signs. I kid you not. You're really paranoid, Mr. Hey, I've been doing this for a while. And for those of you who are getting good marks but making dumb mistakes, I was the king in high school of getting 90s and 80s and 85s because I made dumb mistakes and all the other ones. Oh, it drove me crazy. So this is my emotional scarring. And then they'd pick me last on the basket. Hang on, never mind. Okay. Talk to my shrink later. Logan, can you read me this black equation right here, starting with the y? Nice loud voice. 15,000. Yes? Minus x, which means wherever I see a y, what can I replace it with? 15,000 minus x. So I'm going to go over here. 140x plus 2 15,000 minus x equals 720,000. By the way, can I have a negative number of trees? No. Can I have half a tree? So there are some built-in error checks here. The only way you might end up with half a tree, I'm trying desperately to remember if I made up these numbers or if I actually crunched these numbers ahead of time. If I made them up, we might end up with decimals. Can't remember. I hope not. Could be deforestation? Yeah, okay, fair enough. Good point. I'm getting 140x plus 30,000 minus 2x equals 720,000. You get 138x plus 30,000. Are these bigger, tougher numbers? You'll notice, Grayson, I'm showing way more work, right? If it was 5s and 3s and things I could do in my head, I'd take shortcuts. But you know, I can. Am I dumb already? What?
Oh, no, I just forgot it. Oh.
Did someone else make a mistake? 138x. How would I get rid of the 30,000? Minus it from both sides. 690,000? Does it work out evenly? Oh, what does it work out to? 5,000? Oh, and you know what? I'm even going to say, I bet you can figure out why in your head. Jordan, how'd you get that? Or subtraction, depending, right? You could stick it right into there. Y equals. So 5,000 large trees. 10,000. Now, at least this question I could see being useful if you were trying to plan out a park and you knew you had 2 species of trees that you were dealing with and you knew how much pollution on average each tree could absorb and you had a city goal to absorb 7,200 kilograms of pollution, then you'd know how many of each to buy. I guess. I don't feel this is quite as contrived as some of the previous ones, but even so, in real life, would you have only 2 species of tree? No! You probably have 15 or 20, which, by the way, would mean if you had 15 different species, you'd need 15 different equations with 15 different variables, and you wouldn't bother solving it by hand. You'd crunch it through a computer. So, yeah. You have a take-home quiz because you guys wimped out on me last day. And assignment 4. It means you may have some homework on this lovely sunny weekend. You may be able to get it all done in class, and it's a Thursday, so you can plan to get it done tonight still. Here's your take-home quiz.